Hello, I just wanted to make a video to show off this new quad that I built. This is not a how-to or a tutorial or anything, I just want to show it off basically. As you can probably guess from the thumbnail or the video description, it's extremely light and it's also extremely fragile, but that's okay because I made this for a specific purpose. And if you may have seen one of my older videos from about a year ago, I actually started trying to do what I'm doing with this quad with my old Hubsan X4, and basically what I'm trying to do is get the computer to control it and at least just to hover it for a start. That's the goal. So my overall, where are we? Here we go. Just to list up a few of the main points that were important and those that were not important. Because when you do something like this and you have a very specific goal, it becomes very easy to build something that is exactly what you want. So it's going to be flying indoors, and my room is pretty small, so it has to be small. It has to have a long flight time. That was quite important because I found when I was using the Hubsan X4 to do it, it only got about 5 minutes or so on each battery, and it was a real pain in the butt to have to stop and change things over. And when you're trying to tune the PID settings for something, you have to change the values and try it, and change the values and try it, and it takes quite a while. So having a long flight time is really important. Prop guards was also something that I wanted to have, not strictly necessary, but almost strictly necessary, because it's going to be flying right here next to me, and it's probably going to be bumping into the walls and the curtains and the desk and me probably. So prop guards was something I wanted to have. Not important obviously is payload. Durability, it's not going to be crashing from 20 meters up in the sky or anything. It's probably just going to be a meter or so off the ground at the most. Range doesn't matter. I don't need to be able to see which way it's facing from a distance or anything like that. And one thing that I kind of wanted to have was that it could use the same propellers that I'm using for all of my other quads, which is these gem fan props like this, and they have a 5mm hole in the middle. So I kind of wanted to use motors that could handle having one of these props just stuck directly onto them without having to use spacers or adapters and stuff. So that was my set of requirements, and originally what I did was I bought one of these things, which is called a Super X. I think that's the name actually. Super X quad, mini quad, or nano quad, or something like that. And this actually cost quite a bit of money, and it was a bit disappointing. I won't go into all details here, but yeah, it just really wasn't going to perform very well for what I was trying to do. Although the size is quite nice, I will admit. This is the perfect size for what I wanted. This is 12.5 centimeters across. So I eventually just decided not to bother with that one, and I thought I'd try building something myself. And I'd also just come across these motors here that I'm using, and they're nice and small motors. Now I didn't take any video while I was making this build, so what I'm going to do is just show you a few photos, and I'll just talk about what I did at each step of the way. Let's go back over here. Okay, so this is just a comparison of the three motors that I have for all my quads at the moment. The one in the middle is the one that I have on the so-called cheap-ass quad, and that's 1804 size motor. The one on the left is the one that I have on this very light quad. So these motors are very small. They're only 13mm across. At least the motor, internal stator part of the motor is only 13mm across. So they're very nice and small. The one on the right is my high-performance Sunny Sky 2204 that I have on my other nylon frame quad. And anyway, so I wanted to use these small motors, and I'll just go through some of the other things that I have going in this order. Oops. As usual, I got most of this stuff from Banggood. So these are the motors here. They're $22 for two at the moment. When I bought them, they were $25 for two, so I actually paid $50 for the whole set. And they have quite nice wires on them, so none of that nasty single core stiff wire. These motors have nice braided wires with silicon, what do you call it, silicon shielding. Yeah. You get a bunch of these connectors with them too, which is quite nice, but I didn't use any of that. So anyway, that's the motors. Now this thing here is really the magic of how this quad could be made so small and light. It's 4-in-1 ESC, so all of the 4 ESCs you need, plus the 5 volts step down adapter to use for your flight controller board, is all on this one board. And this is just over 3 centimeters square. So this is really, really great, perfect for what I'm doing. The price is a little bit on the high side. If you consider buying 4 ESCs separately, you'd be paying almost $10 per ESC. So you could get a fairly nice ESC for $10. But like I say, when I'm building something so specific, this was just the perfect thing for what I was doing. The flight controller board I'm using is this NAZ 32 board. Well, it's a mini version of the NAZ 32, as far as I know. Yeah, okay, it says it right there. So you don't have some of the main features that the other one has, but it does actually have a barometer on there, interestingly. And it's quite specific as well. It only supports PPM control, and it only has 4 outputs. So you can't make... oh, wait a minute. 6 motor outputs for multi-rotor. Okay, I was going to say you couldn't make a hexacopter with it, but, well, you definitely can't make a octocopter. I know that much. Anyway, so this is about $20, so that's... I think at the moment this is actually under $17 US, so it's pretty cheap. And it arrived to me in 2 days because this guy actually lives in Japan, so that was quite convenient for me. Although I did have to wait for about 2 weeks for them to restock. So if you want to get one of these and you see that they actually have some available, only 4 units in stock at the moment, you might want to jump on it quickly because they don't produce a whole lot of them as far as I know. So, but anyway, this I heard a lot of good things about this flight controller. So I'd had this sitting around for a while and I wanted to try it with this, and the small size was just perfect. Another few things I got was I got one of these, which is like a vibration dampening mount, and all I'm using from this is the top board. So these screw holes were in the right spacing for me, and it's a nice stiff and light board. So just this part here, that's all I'm using. The prop guards are these ones here, $5 for 4, quite nice. A little bit flexible for my liking, but they became very useful as the template for drilling holes, actually, which I'll get to in a minute. Props, these ones, or you can use any 5mm interior props for those motors. Oh yeah, so one of the other points about these motors is that I like is that they the one is counterclockwise threading and the other is clockwise threading, so you can just hand tighten these prop fasteners and they stay on there quite nicely. And of course the motor shaft, the output shaft, is 5mm, so you can put those larger propellers, even though these motors are quite small, you can just put those large propellers straight on there and you don't need any adjuster spaces or anything like that. And the last thing I got from Banggood was a set of these connectors, just to have something to join the battery on with. Keep in mind if you do buy these that they could well be colored backwards, so you might need to swap them over, so just watch out for that. So anyway, that's all the stuff that I got from Banggood and the Abuse Mark guy, and the total for the build comes to $123. Now, like I say, I'm not going to tell everybody how to do this and how to build it, so it's not going to be like a build guide or anything, but I know people are going to ask, where did you get that and how much it was? So I'm just telling you this in advance before all those questions come. So that's what I paid. That's actually including the $50 that I paid, but if you get those motors now, I think it was, were they 23 each? So that would be, you get about $120, all that stuff. Anyway, so let's have a look at some of the other photos. Yeah, I found out pretty early on that the prop guards are perfectly sized for these small motors. So I think the spacing of the holes is 12 millimeters apart. So that's if you look at the holes as a square, each side of that square would be 12 millimeters, and they're a perfect fit for these motors. So that was really great. Now what I first started to do was to use this other frame that I had for a while, and that's this one here. And I mentioned this in the cheap-ass quadcopter build. This was about $11. Well, it's actually, there's two parts to it, so it goes together like that. And that's how you're supposed to use it. But since I was trying to make something very light, I decided I would just use one side of it, and the prop guards fit onto the other side of these holes here quite nicely. And everything was pretty good, except for the fact that you can see it's extremely bendy. So bendy, in fact, that when you get the motors on there, when I stuck the motors on, you could just shake it like that and the whole thing would wobble like Homer Simpson's belly. So it wasn't really going to do the job, but anyway, that's what I started doing. And you can see the motors are on there with the prop guards, and this would have been, I think, a 25 centimeter quad. So it's not really as small as I was trying to aim for, but it would have still been okay to fly indoors. Another problem though, is you can see that the motor leads, the wires don't quite reach into the center as much as I would have liked. This is where they mounted on the side, so I had to use a little bit of spacing there with some extra nylon nuts, and I put some little rubber grommets in to stop the vibration. Yeah, but as you can see here, this is as far as the motor wires would reach. So from here to here, there's just a little bit of space. It's really oshi. There's a really good word in Japanese. You'd say oshi. It's like close but no cigar kind of. Anyway, so that was a little bit annoying that I would have had to bridge this small gap with some extra piece of wire. But apart from that, it was alright, except for this being a huge problem. So what I decided to do was, I had some pieces of aluminium sitting around, this aluminium here, from something else I was making. And this is, it's 1.2 millimeters thick, like that, by 5 millimeters along that side, by 15 millimeters that way, and 1 meter long, of course. And I got this, and I thought what I would do is I would just stick it underneath this frame to stiffen it like that, just as a reinforcing element. But I didn't really like that idea all that much because it was just adding extra weight. And then I realized that these motors are so small that you could actually drill holes directly on here and mount the motor on there, and this 15 millimeters section is wide enough to do that. So once I realized that, I thought, well, I'll just get rid of that fiberglass bendy frame altogether, and I will make my own frame completely. Now what I could have done, of course, is stick the top part of that fiberglass frame on as you are supposed to, and that would have stopped most of the bending, but that would have added quite a bit of weight, and I didn't really want to do that. So I used the prop guards as a template. So the smaller 4 holes in the middle there are the ones that fit these motors exactly. So I just taped those on there and drilled straight through those. Fortunately, the fiberglass is not soft enough to stop a drill going into it from sideways. Sorry, it is hard enough to stop a drill from cutting into it in the side direction. So they function quite well as drilling templates. So this is what I had here. 4 holes fit in there quite nicely, and then I stuck it together like that. I had to cut a little piece of the side section out here in the middle to get them to overlap nice and flush like that. And there is, of course, a 1.2 millimeter height difference there, but I haven't found that to be a problem, and it's not really a big deal. So that's you can see the frame is pretty small, and without the prop guards on, it looks really, really small. It's just the prop guards that make it look kind of large. And the other nice thing about this arrangement is that the motor wires are pointing directly down towards the center of the frame right from the start, so you don't have to they don't go out at a 45-degree angle like some of the other motors end up being arranged. One little drawback was that I needed another hole in the middle for the motor shaft to have a little bit of clearance, because it's about a millimeter or so. It sticks out about a millimeter or so below the main base of the motor. I didn't really feel like drilling another hole in the middle there, because it was sort of getting a bit cluttered, and my drilling skills without any nice template would not have been so great, I think. Plus the prop guards there, as you can see, they have about a millimeter or so of spacing anyway. I tried just using that spacing, but it wasn't enough. So they needed a little bit more spacing, for which I got this rubber sheet here, which is just a 1 millimeter thickness of rubber. It's a little bit stretchy. I'm not sure what exact type of rubber it's called. It's called elastomer sheet. Maybe, I don't know if that's the English name or what, but that worked out pretty nicely. And I just cut some squares of that, and also cut a hole in the center of that, of course, and placed that in between the aluminium and the prop guard. And as you can see, I've cut this piece of angling away at this point, and the reason I did that was because I wanted to put the prop guard on the top, and I wanted to make the side that had no angling on the bottom, because I wanted to keep that perfectly flat so that batteries could stick directly onto that from the bottom and the angling wouldn't get in the way. And another reason is because I discovered that this ESC board has a bunch of things on it, like, it's maybe a little bit hard to show here, but there's a whatever that thing is, the word escapes me, inductor, I think, sticking out there. And I found if I put the angling on the top, those things that poke out from this ESC board could fit quite nicely in this 5 millimeter gap below there. And if I did it that way, the bottom would remain completely flat. So as you can see, it's not going to focus, is it? But the bottom there where you stick a battery is almost completely flat. So that's quite nice when you come to stick a battery on there. Anyway, so that was the reasoning for why I cut this part away from the top. Unfortunately, that does detract from the strength of the motor mount area quite a lot, as I'll show you a little later. Actually, I'll poke a photo in from my first crash around about here, if I remember, and you can see that this whole section gets bent back. And this was only a tiny little crash, but because the prop guard sticking out so far gives it so much leverage, it was able to just completely bend this aluminium backwards. Now fortunately it's something that I could just bend back by hand and keep flying, but I kind of decided not to fly outdoors anymore after that. Okay, so getting back to the story. So as far as measuring the size of this and making sure everything was going to fit, the largest size it could be made was kind of dictated by the length of these motor wires, because I didn't want to have any more wire on here to extend things. And as you can see, I've taken the blue wires that were on here that came with this speed controller, I've just removed them completely, and I connected the motor wires onto there directly. So that gave me an upper limit on how far away the motors could be from the center. And as for a lower limit on how far the motors could be away from the center, we have to consider how large these props are going to be. Well, we know how large the props are going to be, but I mean how close they're going to be when they spin. And as you can see from this photo, I think this is about 13.5 centimeters from side to side there between the props. So they have around about 1 centimeter in the central area where they do not cross each other. There's a little a 1 centimeter space gap here, and that was about as close as I felt comfortable making them. So that's how we ended up with the size of 19 centimeters, which is actually 192 millimeters between motor to motor diagonally. So as far as mounting things on the middle piece, this was my original plan. I was going to stick that little fiberglass board on there first, and then I was going to put the ESC board on top of that, and then I was going to put the NAS32 and the Arduino Pro Mini on top of that. But I changed that a little bit because, as I said, the ESC board had a lot of bumpy things poking out from it that I wanted to put in this space where the angle was forcing me to have space anyway. So rather than waste this area of space under there, I put the ESC on first, and then I put the fiberglass board on top of there. So that made much better use of the space. And as it turns out, I would have needed some kind of insulating layer between the ESC board and the Pro Minis anyway. And so this was a good place to have it. And what I did after that was I just stuck the NAS32 and the Pro Mini directly onto here with foam tape. And they fit together very nicely. Okay, so this is how the wires joined on. The wires actually turned out to be a little bit longer than I needed in most cases, but that's all right. This cap here, I just bent that around sideways so that it wasn't sticking out so much, and now it just sort of sits in here. Yeah, so this NAS32 mini microboard, or whatever it is around about the same size as an Arduino Pro Mini. And one thing that's really nice is that the raw pin of the Pro Mini and the 5-volt rail of the NAS32 are exactly lined up so that you can connect them like that. So I just soldered a piece of pin header across there like that, and that kind of stuck them together quite nicely, and you can see it's like right at the front edge there is all lined up and everything. So that was quite convenient. And then the other connection you need to make is from ground to ground, so that's also pretty close. So I just wired another little piece of wire across there like that to connect those up. And then the only other connection we need is the PPM input, and I have that on pin 2 on my Pro Mini, and that just comes over to the number 1 signal line on the NAS32. So that's the only connections those two need. And then the next 4 pins here are the signal outs for the motor, for the 4 motors. So I put a pin header on here to connect those up. And then you have these 2 here, or these 2, I'm not sure which ones I used, but so this is the negative rail and that's the positive rail there. So then your 5-volt input coming from the ESC board can go onto these 2 rails here. So you can see, well, it's getting a little bit hard to see, but yeah. At first I used regular plugs. These are the plugs that came with the ESC board. Let's see. So you can see it comes with one of these, comes with this. So that's what I'm using there, and you do kind of need that little plug because it's pretty awkward to connect things without that. Oops, where are we? Here. So that's what I was using there, and that's what it looks like from the side. These the white and the yellow are the 5-volt and negative coming from the ESC. Kind of strange coloring. So it looks like I've put them over there. All right. And these 4 here will be the motor signals. And this was a little bit messy, and I wanted to make things a little bit more secure. So I actually cut these wires and soldered them directly to make it a bit tidier, like that. So now I could take that off, I guess, but this is where you connect your USB connection to the computer to change the settings for the NAS32 board, so I'm just leaving that there. But what I could do is take these pin headers off and solder these 4 wires directly into those holes. So that's everything, I think. That's all the photos I have to show of the build anyway. So I'll put a little bit of video into the on the end of this video. I actually have two videos because I found, I'm not sure whether it's all credit to the NAS32 board being very smooth, or whether just because this quad is so light and it handles very well just by nature of being extremely light. I think it's probably a bit of both, because I have heard a lot of good things about the NAS32 controlling. But boy, is it fun to fly. I mean, it's just such pinpoint like movement. It does everything exactly as you want. And it's also the smoothest to lift off, which I've never seen with the Multi-Wii or the CC3D so far. Like I say, I shouldn't say that it's all to do with the NAS32, because this frame is quite a special frame. But when you take off, it just rises straight up as if there was no ground effect at all. It is quite strange and quite nice. It's a really good feeling. And when you put a 3S battery on this, because it can take 3S, so even though this is very small and light, it could actually carry a Mobius or a GoPro or anything like that as well, because these motors are real, like they're decent motors. They're not the... That's another thing that I like about it rather than this one, because these little motors, you couldn't carry anything with those at all, really. But yeah, so potentially I could put a Mobius or some FPV gear on this, I suppose, if I wanted to. But yeah, with a 3S battery on here, it's just basically a flying battery, and it's just so much fun to fly. So I probably will fly it around outside a little bit more once I've done with my computer controlled testing and stuff. Yeah, it's just really amazing. It'll stop on a dime, literally. You could be flying along at full speed, and if you can control it just right, of course. I only managed to do it a few times, but you can be flying along at full speed, and then if you just slam it like to a 45-degree angle, it'll just stop. It's just like it hit a brick wall and stopped. And of course, to accelerate, it's the same. It just flies off immediately. Lots of fun. But yeah, like I say, I might. I'd like to make another quad that sort of is based on this, but that is a more sturdy version of this, without the prop guards and stuff, just to have fun flying it outside. I think it would be worth doing that, actually. Anyway, so just to show how nicely it lifts off and how controllable it is, I actually flew it right here. Like I have this is just my desk, and I have a little bit of video of that. So I'll show you what I mean about how easy it is to control and how it lifts off with almost no ground effect. So, like I say, I'm not totally sure if it's just something to do with the way this frame is made, or whether it's because it's so light, or whether it's the NAS32 board doing its thing extremely well. But I was hovering there basically 5 or 6 inches off the desk, and there didn't seem to be any ground effect or wobbling that was bothering me. And this is the first quad I've ever seen that with. Even the Hubsan X4 had a ground effect that you had to sort of get up off the ground away from before you could get a nice steady hover like that. One other thing I should mention is that this is the first time I've actually had to modify the PID settings for a quad, and I think the reason for that is because it's just so different, being so light. And I found that with the default settings, it was flying like this. It was hot. The P setting was too high, so I just reduced that from 4 to 3, and I also reduced the D setting from, I think it's 22 or something to start with, and I made that about 18. So yeah, I did actually have to adjust to compensate for the extreme lightness of this. Just while we're here, let's check what the actual weight of this is. I'm pretty sure it's about, so it's 123 grams. Can you see that? 123, just like that. We do, of course, need some props. And a battery. Sorry, I'm a little disorganized here. Where's my... Yeah, battery, alarm. And a battery. So that's, hopefully you can see that says 179 grams there. Where's that light coming from? So that's 179 grams all up weight, and I get around about 12 minutes and 50 seconds I measured with this. So that's just hovering only indoors with no wind. But going back to my goals at the beginning of having a long flight time, I think that's pretty good. So this is a 2S 900 milliamp hour battery. The battery on its own weighs about 44 grams, so it's pretty small battery. It's probably going to be perfect for what I'm doing here. That's 44. Wish I could... Oh, that doesn't help. All right. Anyway, so another long-winded video, huh? I always think when I start a video that it's going to be, 15 minutes or something, and then I just talk and talk and talk. Anyway, so just to finish off, I'll show a little bit of the video that I took when I flew this outside. Like I say, I won't be doing that much anymore. In fact, most of the flying hours that this little quad is going to be doing are going to be clocked up by this Arduino Uno and RF24 connected to my computer. So the computer is going to be doing more flying of this than I am. At least that's the plan. So anyway, thanks for watching, and I'll just put a little bit of video from outside when I flew this from the other day. See ya.